From Informa Tech Target, I'm Beth Pariseau, and this is IT Ops Query. This podcast distills the signal from the noise about enterprise software development and platform engineering. Each week, we'll talk to expert guests about the latest tech industry news and trends that engineering and IT leaders need to know. Don't forget to subscribe to IT Ops Query for more conversations on AI and the future of the enterprise digital workspace. Rob Hirschfeld is the CEO and co-founder of Reckon, founded in 2014, focused on addressing the messy challenge of operating at scale in physical data centers, according to his LinkedIn profile. Hirschfeld has had a front row seat to the last decade of conversations in enterprise IT ops about bare metal server operations and cloud repatriation, topics that remain hot as some enterprises look to move AI inference workloads on premises. Thanks for joining us, Rob.
It's a pleasure. I'm excited to talk about these topics. They really are hot and current in today's market. And it's exciting to see bare metal back in the conversation. So,
indeed, what's old is new again. So, during KubeCon, you and I had a really interesting conversation about the idea of returning to on-premises data centers for enterprise AI. But you pointed out that shift from away from the idea of going all in on public cloud to self-managed hardware has been going on for quite a while. So, can you say more about that?
It really has, and not all people should be running their own infrastructure, but starting, most companies were trying to get to cloud and working very hard at it, and as they started to get into cloud, and we heard this from our largest accounts, who had a cloud first strategy, a multi-cloud strategy, that as those bills started to come in, they found that the costs of running things in cloud were much, much higher than they expected, much harder to control than they were expecting. And so, the reality of what it takes to move everything to cloud and the costs associated with that versus running your own infrastructure and buying actual assets and depreciating them and owning them, the reality of that purchase and the power of owning your infrastructure is really very material for companies. And the more they do cloud, the more they actually start to see, especially for stable workloads, the value of coming back in to what I would call self-managed infrastructure. A lot of people like to say on premises. That can be confusing. We're really talking about when somebody buys the assets and runs the assets. And there's a couple of different ways to do that.
Yeah, like edge computing, right?
Edge computing is one of those things that we've been talking about for a long time.
Yeah.
And the challenge we've had with edge is a lot of edge infrastructure is purchased by the operations teams. So they're very siloed or segmented. They're not really bought in enterprise as IT infrastructure, meaning it's not a shared infrastructure that's managed. So you don't combine the cash registers and the video systems and the stock keeping system. So right now, a lot of companies have edge infrastructure. There's a lot of edge infrastructure, but it's not managed by the IT teams as a shared resource, the way you would see in a managed data center with virtualization or Kubernetes, or the way AI is. Now, AI is so expensive that it's very possible that we're going to show up and say, wait a second, you can't have GPUs for video and for stock keeping and customer analysis and those have to become shared infrastructure. But for us, when we talk about it, it really ends up being a question of this IT shared infrastructure is the bare metal story.
Okay. And so along those lines, when we talked at KubeCon, you mentioned sort of the dynamics around VMware exits since Broadcom. And the role that platform engineers play in those dynamics. And I'm hoping to hear that take from you again, because I thought it was very interesting.
Platform. One of the challenges that we see with Kubernetes in general, and this was an observation that we shared at KubeCon, is that the KubeCon show is really not an infrastructure show. It's an app dev show. And a lot of platform engineering, when people talk about it, is really for application development. It has observability. It has a whole bunch of helping developers run Kubernetes better or manage Kubernetes better or run their applications better. Those platform teams really don't have infrastructure expertise from that perspective. And so, when we're looking at KubeCon, we're not talking, we're not training those teams how to do infrastructure. It's one of the casualties of everybody moving a lot of the new development work to cloud, is that they got very used to, I'll just let Amazon, Google, Microsoft, whoever run my Kubernetes infrastructure for me. And the challenge that you get into, because you frame this with the VMware question, if you're going to exit VMware and and not just move everything to hosted VMs in the cloud, which a lot of companies don't want to do, can't do. We talked about the economics of it. Then they need to have a team of people who understands how to run that infrastructure. You can't substitute VMware without doing that bare metal lifting, without doing storage and networking and all of those pieces. And the platform teams really haven't positioned themselves to understand that infrastructure. It's been stratified or siloed in enterprises. And so when we talk to enterprises, it's really the operations teams and the infrastructure teams that need to get brought up to speed to do a migration from VMware into something. We see a lot of interest in OpenShift virtualization, but there's decades of experience running VMware. It's very standardized. There's a formula for it. The networking for VMware and storage for VMware is very advanced and specific. And Kubernetes hasn't replicated all of that capability. Frankly, no vendor has replicated all of that functionality to the extent that VMware has it. And so any company looking to do that work is going to have people who build the expertise in storage and advanced networking and dealing with that layer. And it's very different. And this was one of my other points at KubeCon. The platform teams are very used to this many cluster methodology. Spin up a new cluster, very dynamic. Machines are coming in and out of clusters all the time. I have 10 dev clusters and 5 test clusters and 3 production clusters, right? And every cluster is different because it has different requirements. And that model doesn't apply to virtualization workloads. When you buy servers, and this is even truer for AI, when you buy a server for running those workloads, bare metal server, it's an expensive investment. And it's networked in a very specific way. It has very specific storage, a lot of times backed by some type of InfiniBand. And those aren't disposable units. They're not easily replaceable. So you don't want to have, I have a couple, I have 10% or 20% of my virtualization cluster unused because I'm waiting for it to rotate through. That's a platform engineering mentality, and it's cloud native and it's amazing. But it doesn't translate well into buying and networking and storage requirements for these AI and virtualization clusters. So there's a little bit of a mismatch.
Right. And also, unbeknownst to many in that cloud native world, there has been, change in how you self-manage hardware since the last time most people thought about it, right? You can't just go back to, because you're going back to self-managed hardware, you're going back to 2005, right?
Yeah, that is one of the things that I really, talk to people about. They sort of assume that if they're going back to bare metal and self-managed hardware, they're going to be back to talking to a 2005 IT team and data center infrastructure. And that's sad, because a lot of the things that we love about Kubernetes and the Kubernetes community is all of this immutable design and GitOps, all these management techniques that are really very productive. And all of those things can and should be applied to modern data center management, right? We talk to customers about rack scale automation, where they use infrastructure as code techniques to define a whole rack and then run it through automated processes. And if they need to change something, they're literally rebuilding the rack. They call it repaving. Repaving that whole rack and rebuilding it. That's a very cloud native philosophy. It requires a lot of automation. This is what RackN does. It requires you to be able to deal with hardware in a very API driven way. And when you do that, you have a much closer to cloud experience. The processes and tools and the capabilities that have been so productive for cloud completely apply on the bare metal side. And so it's really important that you don't rebuild a 2005 data center. with a whole bunch of bash shell scripts and people with
Right.
USB keys running around at night. That's not required. We have incredibly good out-of-band management, lifecycle controls, and things like that.
Yeah, there are even open source projects around that, right? Under the
There are
CNCF?
open source projects around different components of it. What we
Mm,
find is customers really need to have an integrated approach. So,
mm,
the challenge that we see is if you go through and try and build it from scratch, you're going to be connecting a whole bunch of dots together, and that can leave somebody vulnerable to, you know, I'll give you a very clear example that just happened to us. I'm about to do some PSA videos about this. Um, in the new Dell out of band management, they switched some core values to control boot sequence into read only values.
hmm.
Um, and that means that anybody getting new Dell servers using this new out of band management, iDRAC, if they've written automation to control how the boot sequence goes, that automation is going to fail. So it's a very right. And that's I'm not trying to call out Dell. This is normal. We see it for every major vendor.
Hmm.
They have challenges where they fall out of spec or they put in a bug and then they have to patch the bug. But you have to support the the bugged version and the regular version because it takes time to patch. Bare metal is hard, right? I don't want to
Yeah.
gloss over that how bare metal is hard, because people need to think about it going in eyes wide open, and they also have to think through it can be done, it can be managed. These aren't impossible things. They just add complexity that if you're a Kubernetes user who's used to clicking a button or calling an API and getting a working cluster,
Yeah.
there's more that has to be done for it. But it will save you a lot of money to own that asset and run that infrastructure yourself.
Yeah. Yeah. So, from your point of view, has anything about self managed hardware changed since generative AI came on the scene yet?
It has, and that's an important distinction with this. What we're finding is generative AI is it's not a different workload. So it'd be wrong
Mm,
for me to say generative AI has changed bare metal infrastructure, changed how it works. Because
mm,
fundamentally, it's just another use case for bare metal.
mm-hmm,
But it's an incredibly demanding one. And so
mm,
when we look at customers who are doing generative AI or even inferencing workloads, what they're seeing is they have to use the most advanced networking and the most advanced NICs. They have to mix fiber or InfiniBand into their Ethernet, or they're looking at using the latest Rocky specs for Ethernet, which require smart NICs and advanced cards. They drive their storage arrays really hard, and they have to
yeah.
be very on top of how they've been patching and managing, even down to how they patch and manage the SSDs and the cards. Those configurations can make a difference in the performance of the whole cluster because you're sharing memory across a cluster. And all of that means that the traditional tooling that a Dell, HP, Lenovo, Supermicro um, have in the box, those haven't kept up with all of the configuration locations and areas. Some cases, they're not even trying to keep up with with all that work. And so
Mm-hmm.
in an AI system, it's incredibly demanding on the complexity of that configuration, the number of tools, the number of vendors, the details that you have to manage. It used to be that you could go to one of the OEMs, you could get a hardware profile that they've pre-screened and tested for your model gear and download that and apply it. In AI clusters, it doesn't work like that. The systems are changing too fast. They have bugs and patches. They come out with a new version. You have to if you rebuild the system, you have to reapply all that. It's a very demanding use case of how these things work. And the AI infrastructure is so expensive. We're talking $250,000 to $500,000 per server.
Wow.
That if you're going to take even hours, but a lot of times we see days or weeks for a
Mm,
system reset. If it takes you that long, you're burning thousands and thousands of dollars in depreciation costs for the machine, let alone the opportunity costs of not having the machine running. And so the pressure to manage an AI infrastructure and have it in service, patched, put back in service is incredibly high. And so no, there's nothing special. And yet the pressure, the intensity, the complexity are all, kicked up a notch.
Yeah. So it's so hard to make predictions in Gen AI, but
Yeah.
going to ask anyway. How do you think these conversations are going to change going forward? And what should enterprises know that they don't know about self-managed hardware in 2025 and 26?
Wow. So what we see, it's an interesting time with this because we see, there's still some commodity shortages, still hard to get gear. It's expensive to get gear.
Yeah.
And we see enterprises still pulling back a little bit from making big commitments. They don't know what to buy. They're not ready to commit $250,000 or per server to get this infrastructure. And even if it's just for inferencing, they're still nervous to know what to buy and move forward. This is exactly the same thing with moving off of VMware. If you don't know exactly that what you're going to buy is going to work, you're going to have a degree of pause while you figure that out. And that's what we see at the moment with enterprises. They know they need to do this, and all of the roadmaps for our customers and prospects include moving to more and more AI, more and more GPU in their infrastructures and in their architectures, and commingling that with their normal workloads. So today it's very easy to say, oh, I have an inferencing cluster, or I have a training cluster, and those are special. They don't conform to anything else. They have, InfiniBand networking, and they're managed by a specialist team. None of our customers expect that to be the long-term trend. We're going to come back in to AI being commingled with regular enterprise workloads, especially with agentic. I think agentic is going to light this on fire, where we're starting to take AI requests and put them into standard applications and have agents access standard applications and data. But that means that companies have two challenges. One is they have to buy this very expensive gear and then put it into service quickly and use it. And there's a huge, I think data sovereignty is a good word, although it's, data sovereignty usually implies nation state. But the idea of the enterprises that we talk to sending data in and out of their networks to use a third-party service is really unattractive. This is incredibly sensitive data. It's, praying by the token is a very expensive way to run is very expensive. And so we see companies wanting to pull those GPUs back in so they don't have to worry about per token processing, and they don't have to worry about very sensitive data or potentially retrained or highly trained models leaking across boundaries. So, I don't think this is a 2026 moment here. I think companies need to figure out how to do this. But everybody we talk to expects that they will own this for all the reasons I just laid out.
It does seem real, like it is happening, but I think it may be a bit of a shock to some folks who've gotten used to the cloud native world. And I also wonder, I mean, we hear so much about skills and skill shortages as is in IT. I wonder where the people to do this work are going to come from.
That's one of the sad things, is that with the migration to cloud, we've really lost a generation of people who understand bare metal infrastructure and things like that. And we do see this a lot with, people trying to build up, they're rebuilding it from scratch. The good news is that we've been able, so this is really drives back to Raken's mission, we've been able to commodify that bare metal expertise and make it so that you're not, learning how to set firmware and manage firmware. It becomes much more of a, you're going to tweak and tune some knobs rather than having to build the whole system behind you. And that's transformative, because then you can ask for help. One of the things that's been really sad to me as in the industry for 25 years now is, data center operators have not had a lot of resources to get help. It's, you buy a server, you get an operating system, but tuning it, tweaking it, understanding a best practice, that, with the exception of VMware, because that was their differentiation, we really haven't had people who can get operational assistance. And so the standardization that we've been able to put in there means that we can bring a lot more expertise into people's operations without causing them to, have to be following a very narrow path. And that's important. Nobody wants to build exactly the same thing that everybody else has. This
Right.
idea of a completely rigid definition, this converged infrastructure story, for our customers isn't that attractive. It locks them in. And so we really want to be able to help people do a better job, keep up with the latest changes and buy multiple vendors and not get locked into platforms the same way. Get help so that we can say, oh, wait, somebody else learned a better way to configure this network card, or this interface, or this way of doing things is an improvement. If we can share that between people, then we get some benefits in the industry. One of the things about that 2005 data center we kept talking about was that each one was different and nobody was learning lessons and helping each other. And the industry really rockets forward when we're able to take common practices and improve. And that's been missing from bare metal for quite some time. And frankly, nobody has the time or the money to let AI infrastructure be reinvented or bespoke.
Yeah. So where could people start right now if they're looking for help with this?
This is something that we're doing a lot of, both in general rec-end is, we are trying to produce a lot of education materials to help people learn how to do these processes. We're always happy, especially from a customer perspective, to be able to, bootstrap somebody and get them moving into a fully autonomous infrastructure, right from the start. And that's one of the ways to get help, finding vendors who are neutral or and can move you forward from a process perspective. And I think this is the thing that I would recommend. I don't want to throw you into a buy product from me answer to this question. It's a much more reasonable thing to talk to people about process. And so I think the thing that you want to have conversations with your vendors, you want to have conversations with your teams about how do they build sustainable process? How do they, how are we looking at integrated solutions, right? Fewer silos, more things working together. Those are the answers that to me differentiate the short-term fixes from the long-term. When we talk about the companies that are doing AI, trying AI pilots or OpenShift, we do a lot of OpenShift virtualization pilots. Those pilots are struggling because they don't think through what is the processes I need to put in place to move this into production. They just build something by hand. You and I met when we were talking to somebody who had literally bought millions of dollars of AI gear and then spent a month building it by hand and wasn't sure how they were going to recreate that experience for again and that when if you're sitting down and doing that work and thinking you're going to learn and invent a process as you're going, you're already behind. You're never going to recover from that perspective. So you want to start from a place where your team and your vendors can answer, how do I update? How do I patch? What's my automation? How do I move this into scale? Right. It's going to feel like you're asking, sort of these second stage questions first. But we have seen over and over that the people who have good answers for what that day two process looks like, they have a much better experience actually moving through the learning curve because they've already thought through, how do I iterate quickly? How do I keep things patched? How do I do these updates? How do I coordinate with other teams? Those are the places where people really fail in these deployments. Or, as we've seen a lot of times, people trying to replace VMware, they run a pilot, they get it done, and then the next team shows up and says, well, that won't work for me. And they just spent 6 months building, a virtualization pilot that didn't account for, how you get into production, or it's not running on the right servers, or the storage arrays don't match, or right. All of those things that the process parts of how you integrate into your organization make a difference. Fundamentally, we love helping people do a better job run this infrastructure. It is really important to me that companies have autonomy, that they don't lose, something as core as their IT infrastructure to a third party. And that's been, a driving principle for me since I got into the industry. So I really appreciate these deep questions, helping people understand how they can better manage infrastructure again.
That's good advice. And I appreciate your unique perspective on all this, Rob. So thank you very much for taking the time. Thank you for tuning in to IT Ops Query. To learn more about enterprise software development and platform engineering, explore our content on Informa Tech Target sites. Find us on YouTube at our channel, Eye on Tech. Subscribe to our podcast to receive the latest episodes as they drop. And if you liked what you heard today, give us a rating and review on Apple, Spotify, or wherever you're listening. Thank you for joining us.